Before we jump into today's topic, let me ask you something. Have you ever heard two scientists use the terms GPC and SEC like they're talking about two different techniques? Well, here's the twist. They're actually the same technique, viewed through different historical and scientific lenses. In this video, we're breaking down the terminology in size-based chromatography so you can finally understand the difference, the story behind it, and when to use which term. To understand GPC versus SEC, we need to go back in time. In the late 1950s, polymer science was booming. Researchers desperately needed a way to measure polymer molecular weight without destroying the sample. Then, in 1963, Waters Corporation introduced gel permeation chromatography, or GPC. The name highlighted the gel-like packings used inside columns back then. Meanwhile, in Europe during the mid-1960s, another group of scientists preferred a more universal name, size exclusion chromatography, or SEC. A term focusing on the separation mechanism rather than the column material. So two names emerged, but for the same underlying concept. Think of GPC or SEC like a molecular obstacle course. Inside the column are millions of tiny porous beads. As a sample travels through, large molecules can't enter many pores, so they shoot straight through and elute first. Smaller molecules wiggle into these pores and take longer to escape, so they elute later. That's it. No bonding, no chemistry, no interactions, just separation based purely on size. Or, more accurately, hydrodynamic volume. This is the terminology truly separates audiences. When someone says GPC, they're usually talking about synthetic polymers dissolved in organic solvents like THF or chloroform. Think polystyrene, PMMA, PLGA, classic polymer chemistry. But when we hear SEC, it usually refers to biomolecules analysed in aqueous buffers, typically at physiological pH. Proteins, nucleic acids, polysaccharides, all handled using gentle conditions to keep them folded and stable. So while the technique is the same, the solvents and analytes define which term is most appropriate. Now you might ask, why does any of this matter? Because in chromatography, terminology isn't just vocabulary, it signals experimental conditions. If a scientist says they ran GPC in THF at 35 degrees Celsius using polystyrene standards, we instantly know this is synthetic polymer work. But if they say SEC in PBS at pH 7.4, we know it's likely proteins or biomolecules. Using the wrong term could mislead reviewers, confuse collaborators, or even cause errors in method replication. This is where many chromatographers get tripped up. Calibration in GPC versus SEC is not interchangeable. In GPC, we use polystyrene standards, long, flexible chains that coil in solution. In SEC, for proteins, we use globular protein standards, compact, folded structures. Even if two molecules have the same molecular weight, their shape is different, and that changes their hydrodynamic volume and retention time. This means calibration curves are not universal. They depend on how your analyte behaves in the solvent system. Using the wrong standards can give you completely misleading molecular weight data. Let's look at two real-world scenarios. First, medical implants. PLGA used in biodegradable implants must have very specific molecular weight distributions. Using GPC in THF allows us to track degradation, for example, from 100 kilodaltons down to 60 kilodaltons, which directly affects how long an implant lasts in the body. Second, protein therapeutics. SEC in PBS is essential to detect protein aggregation. Just a small percentage of aggregates can destabilize a formulation or trigger immune responses. Same principle, different solvents, different analytes, different real-world impact. So here's the rule of thumb. Use GPC when you're working with synthetic polymers in organic solvents. Polystyrene, PMMA, PLGA, classic candidates. Use SEC when you're dealing with biological molecules in aqueous buffers, proteins, DNA, polysaccharides. And when you're presenting to a mixed audience or writing something that spans multiple disciplines, use the term size-based chromatography. It's inclusive, technically accurate, and avoids confusion. Before we wrap up, here are some practical tips you can start using today. First, always match your calibration standards to your analyte's chemistry and shape. Second, keep your mobile phase extremely clean. SEC columns are sensitive to particulates. Third, control temperature carefully because viscosity changes can shift retention times. And finally, consider multi-detector setups, like combining light scattering with RI or UV. This gives you absolute molecular weight, branching information, and better sample characterization. In the end, GPC and SEC are not different techniques. They're different scientific traditions born from different applications. Knowing the terminology helps you interpret results correctly, design smarter experiments, and communicate clearly across fields. If you enjoyed this deep dive into size-based chromatography, make sure to subscribe for more content on polymer characterization and analytical chemistry. Thanks for watching, and drop your questions in the comments below.